Hi everyone. You just learned exponential functions, which has the form y is equal to b to the x power. Today, I am going to introduce the inverse of this exponential function, which is called the logarithmic functions. Logarithm, or we call it log in short, is the opposite of exponentiation. Just like square root is the opposite of square, cube root is the opposite of cube, and so on. You can use logarithm to solve exponential equations like 3 to the y is equal to 8. First, let's try to understand the relationship between logarithmic and exponential forms. A little note here, since the exponential function y is equal to b to the x with the condition that b has to be positive and b cannot be 1, it's 1 to 1. Why is it 1 to 1? Because if you look at the graph of an exponential function, it either goes this way or this way. Either way, it will pass the horizontal line test each time. Therefore, it is 1 to 1. And because it is 1 to 1, we can claim that it has an inverse function. So with y is equal to b to the x, the inverse of that would be x is equal to b to the y as we interchange x and y. However, to finish finding the inverse function, we need to solve for y. And that's where the logarithmic function comes in. Definition: for x being a positive number, b is positive and b is different from 1. We have y is equal to log base b of x. It's called the logarithmic function base b of x, where y is equal to log base b of x if and only if b to the y is equal to x. So note here, b to the y is equal to x is the inverse function of the exponential function y is equal to b to the x, as we just mentioned. And we're saying that this function is equivalent to this log function y is equal to log base b of x. You would read this as log base b of x. Notice that in this exponential function, the base here is also b. So why do we need this log function? For example, let's say we have an equation such as x is equal to b to the y, and then you want to solve for y, which is an exponent here. Then to solve for y, you would use the log function. Y will be equal to log base b of x. Another note here, exponential function y is equal to b to the x and logarithmic function y is equal to log base b of x are inverses of each other. Therefore, their graphs will be symmetric along the line y is equal to x. We're going to do two examples. In these two examples, we are going to practice how to convert from one form to another. So in example 1, everything given to us are in logarithmic form, and our goal is to convert to exponential form. What it means is what's given to us is log base b of x is equal to y, and then you need to convert to the form x is equal to b to the y power. So looking at the first example, log base 2 of 16, I can see that my base is 2, so b is 2, and x is 16, and y is 4. And right now, x equals 16 is being the input of the function, and y equals 4 is being the output of the function. So when you convert to exponential form, the roles will reverse. So the input will become the output. So the input x will become the output in this new function. The base will be the same, base 2, And then the output y will become the input y, or the exponent in this case. Now this makes sense because 2 to the 4th power does give you 16. Example B, log base 10 of 1 over 1,000 is equal to negative 3. So right now, this is the input of the log function, but it will become the output of the exponential function. So that will be 1 over 1,000 is equal to base, the base is 10, and then to the negative 3 power. Is this true? Yes, it is, because 10 to the negative 3 is the same as 1 over 10 cubed, and 1 over 10 cubed is equal to 1 over 1,000. If it helps, you can do this. Here's the base, need to be raised to this exponent, and that must equal to this number inside of the log function. So let's try to draw the arrow to see if it helps us determine faster. So this base raised to this exponent must equals this. So we have 6 to the 0 is equal to 1. That is true because anything being raised to the 0 power will give you 1, except for 0 to the 0. Example 2. Write each equation in logarithmic form. So this is the opposite. X equals b to the y is given, and we need to convert it to the logarithmic form. So we're going to start with log. What is the base? The base here is 3. And the output for the original function will become the input in the log function, and that is equal to the exponent 4. Example B, this will be log base. The base here is 10 of 10,000. That will equal to 4. And the last one, log base 1 over 8. Now we always want to make sure that the conditions in the definition is satisfied here. Remember, the base has to be positive and different from 1. And in our case, our base is 1 over 8. So it is still a positive number and it is different from 1. So we can convert it to a logarithmic function. So log base 1 over 8 of 64 is equal to negative 2.